Howdy AGP students, this is Chris, your math instructor. During this session, we'll be discussing the backdoor math strategy. This technique allows you to limit the algebra while taking the SAT and maximize your use of arithmetic. Remember, the less algebra you can do, the better. Let's jump right in. With this strategy, we'll require two important conditions to be met before proceeding. First, the problem must contain algebraic variables. On the SAT, these variables will always be italicized, so be on the lookout for that. Second, an algebraic variable must also be included in the answer choices. If both of these conditions are met, you know that you can use the backdoor and avoid using complicated algebra. Now we'll discuss how we actually implement the backdoor strategy. To use this strategy, you simply make up numbers for the variables. Now that might seem a little bit crazy, but you can actually do that. Of course, there is a catch. The numbers you make up must satisfy all the constraints outlined in the problem. If this does not make sense now, we'll cover this in an example later. When you do choose your numbers, try to pick numbers that will make your math simple. You don't want to make your math difficult. Also, be sure to avoid using numbers like 0, 1, or 2. This will limit your work later on. If the problem involves angles, avoid using 30, 45, or 60 degrees. After choosing your numbers, plug them into the equation from the problem and calculate the answer. Now simply insert your made-up numbers into all the answer choices and calculate each resulting expression. Compare each answer choice value with the answer from the problem. If only one matches, that's your answer. Bubble in and move on. If more than one of your answers matches, your job is not quite done. With the backdoor strategy, you must evaluate each answer choice. It's very important. I can't stress this enough. Some numbers, no matter how hard you choose to try to choose good numbers, they will result in two or more of the answers agreeing with the answer from the problem. If this happens, no big deal. If you do get more than one correct answer choice, simply make up another number. Be sure, though, that it does meet any constraints set forth in the problem. Now, we'll only be concerned with the answer choices that matched from the first attempt. Complete the same process as before, with only the previously correct answer choices. This should result in only one answer choice matching the answer from the original problem. Bubble in your answer sheet and move on to the next problem. Now that we've covered the strategy, let's dive into a couple of practice problems. Example problem 1 states, in a high school club that has 50 students as members, 20 members are seniors, N members are juniors, and 2N are sophomores, where N is an integer and 0 is less than N is less than 10. If the remaining members are freshmen, then in terms of N, what percent of the members are freshmen? Well, there's a lot of variables in there, and you can see they're italicized so they pop right out at you. And that we also have some constraints in this problem. So this is what I was talking about before. We will have to ensure that the made-up number that we choose is between 0 and 10 because of the constraints. Immediately, we should also recognize that each answer choice has the variable n included in the answer. So this is a prime example of a backdoor problem. If we tried to solve this problem using regular algebra, it might look a little tough. So that's why we want to make sure that we use the backdoor strategy anytime we can. We're going to start by choosing a number between 0 and 10. For this case, we'll choose, let's say, 5. Now that we've chosen a number for n, let's gather the information from the problem about the rest of the club. So we can see that the total number of students is 50, and of the 50 members, 20 of them are seniors, n members are juniors, and since we chose n to equal 5, there are 5 juniors, and there are 2 n sophomores. And again, we'll go to the calculator real quick and multiply out 2 times 5, and that gives us 10. So there are 10 sophomores. Now if we want to find out how many freshmen there are, we'll have to actually do a little bit of math, and because we do know that there are 50 students, we can subtract these other classes from them and calculate how many freshmen there are. So we'll enter 50, that's the total number, minus the number of seniors, which is 20, minus the juniors, which is 5, minus the sophomores, which is 10, and that gives us 15. So we have 15 freshmen. Unfortunately, the problem isn't just asking for how many freshmen there are. They want to know the percent of the members that are freshmen in terms of N. So now we need to find out, we know we have 15 freshmen, so of the total club, what percent are freshmen? So to do that, we just simply divide 15, the number of freshmen, by the total number of students that are members of the club. So 15 divided by 50, and that's going to give us a decimal, and that's going to equal 0.3. Let's check that real quick on our calculator. So 15 divided by 50, that equals 0.3. And so that decimal, if we want to turn that into a percentage, we need to multiply that by 100%. So multiply by 100, and that gives us 30%. Now that we have the number of freshmen in terms of percentage, we have an answer for this problem. Now we can go down to our answer choices and start plugging in the answers. So make sure we write down that freshmen do equal 30%. So let's go with answer choice A. Answer choice A is 7 times N. So we can multiply that out. Get our calculator real quick. 7 times 5, and that equals 35. So 35%. That's not the same as 30, so that's not going to be our answer. Answer choice B. This is 30 minus 3 times N. So let's plug that in, and again we can go to our calculator, plug in 30 minus 3 times 5, and we'll get 15%. And again, that's not 30%, so that's not the correct answer. Let's move on to answer choice C. That's going to be 50 minus 3 times N. So let's go ahead and plug that into the calculator. 50 minus 3 times 5, and that equals 35. So 35%, no, that's not the same as 30. So let's move on to answer choice D, and we'll calculate answer choice D, which is 60 minus 6 times 5, and that equals 30%. So that does match. So D is a viable answer choice. But because this is the backdoor strategy, we need to make sure that we plug in all the answer choices. So we'll move to answer choice E now, which is 100 minus 6 times N. So we'll plug that in. 100, sorry about that, 100 minus 6 times 5, and that equals 70%. So again, 70% is not 30%, so we're left with one answer choice that matches, and that's answer choice D. So answer choice D is our answer, and at this point you would bubble that answer in and move on to the next problem. We'll now move on to example problem number 2. Example problem number 2 states, if a square's area equals x, which of the following expressions gives the perimeter P in terms of x? So let's look at this problem. We can see that we have some variables in the problem, x and p, and if we look at the answer choices, all the answers they do have the variable x in them. So again, we can recognize right away that this is a backdoor problem, and we need to pick a number and then work through the problem. For this problem, we'll choose x equals 4. So if we choose x equals 4, and we use the area problem for a square, which is area equals side square, what we can do is use our calculator to find out what one of those sides are. So if we have area equals side square and our area equals 4, if we take the square root of 4, that's going to give us one side. So one side is 4, and now we need to calculate the perimeter. So the perimeter is calculated by adding all the sides. And since the square has 4 sides, we'll simply add 2 plus 2 plus 2 plus 2. And so let's go ahead and do that. 2 plus 2 plus 2 plus 2, and that's going to give us 8. So our perimeter of the square with an area of 4 is 8. Now that we have this answer, we can plug our value for x of 4 into the problem and see what we get. So let's start with answer choice A, and answer choice A is x over 4. So we'll go ahead and do that. So x is 4 divided by 4, our answer is 1. That is not 8. So we'll move on to answer choice B. Answer choice B was x squared divided by 2. So because x was 4, we'll square 4 and then divide that by 2. And this gives us 8, which is the perimeter. So this is a viable answer, so we'll hold on to that one. But because it is the backdoor strategy, we want to go ahead and answer or solve the rest of the answer choices. So again, with answer choice C, our equation is the square root of x over 4. So we'll put in 4, take the square root of that, and then divide by 4. And that's going to give us 0.5 or 1/2, and that's not 8. So we'll go on to answer choice D, which is 4 times the root of x. And so let's go ahead and get the root of x and multiply that times 4. And that's going to give us 8 also. So another viable answer. And this is where you can see where some answer choices will come out with the same answer. And this is a good example of that. Now we're not done yet. We still need to go with answer choice E. And answer choice E is 2 root x. So let's go ahead and plug that into our calculator. X is 4. We'll take the square root of that and then multiply it times 2. And that's going to give us 4. So we know that 4 is not the perimeter when we use x. But, like I said, we do have 2 answers here that do equal 8. So now, like we said in the introduction, we want to actually choose another number that we can use and then plug those into our other problems. So in this case, let's go with 9. That's another perfect square. So we'll use 9. And that's going to give us a perimeter of 12. And we can do that real quick. So if the area of the square is 9, that's going to give us the square root of 9 is 3. So each side of the square is 3. And if our perimeter is side plus side plus side plus side, that's going to be 3 plus 3 plus 3 plus 3. And that equals 12. So our perimeter is 12. And since we now have those answers, we can continue on with the problem. Answer choice A we don't have to worry about. We already know that's incorrect. Answer choice B, however, was correct in the last, but when we used 4. So let's go ahead and plug our x into answer choice B. So that's going to be 9 squared divided by 2, and that equals 40.5. That does not equal 12, so that answer is not correct. Of course, answer choice C we already know is incorrect, and answer choice D, now let's look at that. So 4 times the root of x. So since we're using 9 as x this time, we'll take the square root of that and then multiply that times 4. And sure enough, that gives us 12. An answer of 12, which does agree. And again, we did know previously already that answer choice E is not correct. So at this point, we can go ahead and bubble in choice D and move on to the next problem. And we'll go ahead and look at example problem number 3. In example problem number 3, if p plus r plus 1 equals n squared, then which of the following is the average or arithmetic mean of p and r? And so you can see here again we have the variables in the problem and also in the answer choices. Now this again is if you try to do this algebraically, it might look a little overwhelming, and just looking at the answer choices, they look a little complicated. So this is a great time to use the backdoor play, and I encourage you to try this. Again, just like before, we'll go over this example in class, but go ahead and take some time now and try to work this problem out using the backdoor strategy. The key thing with these strategies is recognizing them and then practicing them, so that you can easily recognize them, and when you're taking the SAT, you can jump on these strategies and solve the problem much quicker. That's all for today.